Alright, so let's get started with talking about the matrix products. So I'm glad that I see Renita has mentioned the dimensions of the matrices. Let's start by talking about that. Okay? So anybody wants to tell me what is the order of the matrices? Well, what is the order of the first one and then the second one? So who wants to tell me what is the order of this first matrix? And I know I saw Renita put it there in the chat. She said that the first matrix is of order 2 by 2. Alright, Lindsay said 2 by 2 as well. So we all can agree that the very first matrix that we have in this product is a 2 by 2 matrix, right? Yay, nay. Okay, yes. So I heard a yes. I'm seeing another yes. Alright. Now, Lindsay is saying that the second matrix is a 3 by 2. And I believe Renita had put in the chat earlier that she says the second matrix is a 2 by 3. So which one is it? Is it a 2 by 3 or is it a 3 by 2? So I'm going to come across to the meeting now. Raise your hand if you agree with Renita. So do you think the matrix is a 2 by 3? Raise your hand. So I see Zahira raise her hand. Kalissa, Ashley. Alright, look at that. We have some hands going up. So I have about 8 hands. Wow, look at that. So we have, yes it is, row by columns. Beautiful, Renita. And you have 13 of your peers in agreement with you. Alright, so even Lindsay just checked back and she said the answer is 2 by 3. So for those of us who were able to identify it as a 2 by 3, excellent work. It is a 2 by 3. And once we know how to identify the dimensions, once we know how to state the order of a matrix, we won't have any issues when it comes to doing things like our matrix algebra, because this plays a very important part in being able to do the multiplication. Okay, so oh, look at that. So Mayasha got a response. So we'll see if Mayasha's response is correct in a little bit. Okay, now for those of us who said we got nothing, can you tell me, just by looking at the dimensions of the matrix, the two matrices that we have here, can you tell me whether or not these matrices can be multiplied by each other? So if you think the matrices can be multiplied by each other, raise your hand. So I see 3 hands up. Is that from before? Okay, so I see some hands going up. Oh, look at that. Number 7. Okay, so hands up if you think the matrices can be multiplied. Now that you're looking at the dimensions of the matrices, can you identify whether or not these matrices can be multiplied? So I have, make that 10 hands up now. 10 hands up. So hands down if there is a volunteer, whether you be from the 10 who raised your hand or from the other 15 who didn't respond at all. Make your choice and tell me, why do you think these matrices can be multiplied, or what is your validation for the matrices being able to be multiplied by each other? There we go. Thank you, Dominique. The inner numbers are the same. What is the word that we use to refer to matrices which can be multiplied? Where you see this thingy happening here, the inner numbers being the same. What is the word that we use to refer to that? So it starts with a C. Let's see, did Kalissa get it for us? Let me see. So Kalissa is saying, oops, I clicked the wrong thing. Ugh, today I am feeling very special. Ah, there you go. There you go. It is conformable. Alright, so she maybe had a little typo on the end there, but conformable. This is the word that we use to refer to two matrices which can be multiplied by each other. And conformable matrices are easily identifiable by the fact that the inner dimensions of the matrices, when you write it out like we did here, this is how you identify your conformable matrices. Okay? In other words, if the number of columns in your first matrix is equal to the number of rows in your second matrix, conformable matrices. That's how you know you can multiply them. So now that we've recapped that little part, for those of us who said before they couldn't get a response or they could not get some product, do you think you can get a matrix now? Do you think you can get a product now? Alright, so even Sasha got a response as well. So we'll check to see. So I saw Sasha and Mayasha both have responses. They look slightly different, so you're going to see who is correct in a little bit. But for those of us who couldn't do the matrix multiplication before because you were unable to identify conformable matrices, now that you can identify conformable matrices, alright, fix it up. No problem. But yes, this is how you'll know if you can do your matrix multiplication or not. Okay? So, conformable matrices. These two are in fact conformable. Let's talk about doing our multiplication now. So, if I'm going to multiply these two matrices, as Dominique mentioned earlier, she said, we have to multiply row by column. So, before I continue, can anybody tell me what they think the dimensions of the product matrix will be? Even Shemaya has a response in the chat. That's nice. Okay, so yes. So a 2 by 3. Who said that? Is it Mayasha? Lovely. So Mayasha is saying that when we multiply these two matrices, we're going to get a 2 by 3 matrix. Okay? And the reason for that, if you all can recall just now with the dimensions, the inner numbers lets us know whether or not we can multiply the matrices. And the outer numbers, these guys here, this 2 and this 3, this one actually hints to us what will be the dimensions of our product matrix. So, this is how we know we're going to get a 2 by 3 matrix. Alright? So now let's work on the product itself. So we do know that we have to do row by column, and what I always will encourage you all to do, take your time with it. If you know you're the type of person you're going to have a hard time with doing your multiplication, take your time. Okay, so my very first element, my first row, first column in my product matrix will be as a result of multiplying my first row in my first matrix by my first column in my second matrix. Okay, so in case we can't remember that we multiply like this is what you will write. You are going to do 5 by 2 plus 4 by 0. Okay, so does that look familiar to us? Anybody, does it look familiar to you? Somewhat familiar? Yes. So for those of us who can't recall how to do our matrix multiplication, this is what you're doing. Okay, so that's my first row, first column element. Now let's say I want to get the first row, second column element. What am I multiplying? That's it. First row by the second column. So we're going to do this row by this column. Alright? So again, do the same thing. This is my first row, second column here. So it will be 5 by 1 plus 4 by 3. Alright? And then final row, well, final element in the first row. if I do my first row by my third column, I'm going to get this element over here. So that's going to give me 5 by minus 4 plus 4 by 6. Right. 6. And I think I just saw Sasha check back her answer, so that's very good to see that you're checking over. Right. Okay, so again, we're going to repeat the same process, but this time you'll do it with the second row of your first matrix, because now we're working in the second row of our product matrix. It's second row by first column, and that will give us this element here, and second row by second column, and we get this element here, and then second row by third column, and we're going to get our final element. So in total we have 6 elements to get. So now let's work this out and see what we get as our final matrix. Alright, so this is minus 3 by 2 minus 3 by 1 minus 2 by 3, and then final one. So the only thing, like I would say, when it comes to matrix multiplication, for those of us who, have trouble being able to like do that mentally, it will be a time-consuming task to write out all the products, but it will save you the issue of having to like recheck and doubt yourself, because you'll have your entire process outlined, so you can see where you make your mistakes. And like I would say, it is better to get your work done properly than to try to do it mentally and quickly and not execute it correctly. Alright, so minus 2 by 6 now. Alright, so let's work this out and see what we get. Okay, 5 2's are 10, plus 0 is 10. 5 by 1 is 5, plus 12 is 17. Cursor, nice. Alright, 5 by minus 4 is minus 20, and you see this directed numbers thing? Hey, make sure you fix that, especially if you're always struggling with it. So, minus 20 plus 24. Minus 20 plus 24. We should get 4. Then we have minus 3 by 2 is minus 6. Minus 2 by 0 is 0, so I just put minus 6 here. Minus 3 by 1 is minus 3. Plus minus 2 by 3. Minus 2 by 3 is a minus 6. Minus 3 plus minus 6 is a minus 9. Alright, so like I was saying, if you know your undirected numbers don't get along good, you definitely want to make sure that you go take your time, write it out step by step so you can work on it. Okay, and then finally this one, minus 3 by minus 4 is a positive 12, plus minus 2 by 6. Minus 2 by 6 giving us a negative 12. So positive 12 plus negative 12 will give us 0. So for those persons in the chat with 10, 17, 4 in your first row, and then minus 6, minus 9, 0 in your second row, excellent work. That is the answer. So there you go. For those of us who didn't recall how to do a matrix multiplication, we've gone back over it. Remember, always start by looking at the dimensions of your matrices. Make sure that you can identify whether or not your matrices are conformable. Do not ever forget that word, conformable. And then we go row by column. And you all saw the procedure for row by column. Take your time with it, row by column. And then finally, once you get that out, and you have no trouble with directed numbers, you'll be able to get all the elements for your matrix. Okay? So